Well, hi, good morning. Thank you so much for joining me here. It's June 27th. A beautiful day today. Hot sun and cool air. Very cool here. 11 degrees to start this morning. And the high is only 21 or 22 or something like that, which is very cool. Fantastic. I should be outside, but I'm in here in my shop. So, what to do today with this radio? If I remember right, there was a number of capacitors just waiting to come out of this radio. Flip this right back this way. Yes, the bundle of three bad guys here. Maybe I'm going to... How well was this radio working just before? I can't remember. Maybe we'll start by just playing the radio again, and then we'll pick off these capacitors in some order. See if there's some kind of deficiency or improvement that can, be detected, be heard, rather than just do the three of them. Okay, so the name of the game is to play this radio. Now, I don't have the antenna switched on here. Pretty sure I have it switched into another location. Okay, I'm going to start up the radio and head down and turn on the antenna. Okay, I don't think we heard quite enough of that interesting thing he was saying about the effect of certain kinds of music on your brain. So anyway, I know music I like makes my brain happy, and music I don't like doesn't work that way. So that's how it goes here. Now, what can we hear from this radio here? The staticky sound in that has nothing to do with the radio; it's interference. Now, as I tune across the band, you can hear kind of the same noise the whole time. That sound, not changing. I tune in a station, the sound goes down. Well, that's just because AVC is desensitizing the radio. Is that noise coming through the IF? This is a question I've begun asking a few radios ago. Can you have a noise signal at the IF frequency? This radio be 455 or so, and that noise is going right through the radio and coming out the speaker. It doesn't matter where you tune this. That appears to be the case here. I did examine the noise situation in my I'm going to get another radio. We're going to take a look. Okay, I'm going to shut this one off so we're not hearing anything from it. So I bought this radio specifically to hunt for noise in my house, and use as a radio, but more software-defined radio. Nice little radio. Little awkward to tune and use, like all these radios that have so few controls on them. One control. It gets a little complicated to use it. So right now it's tuned to broadcast band 1280. That's roughly where this radio is tuned. Now I have to operate the menu, I have to push this button in, but if I don't do anything for 2 or 3 seconds, it'll think I'm asking it to memorize or put into memory this frequency. So you have to push it in and then do something. If you watch the red indicator, it'll travel around as I turn the knob. I want it to come down to here where you turn the speaker off and on. There we are, speaker on. And that's what we hear out of this radio. And what I'd be hoping to see is, I don't know, some kind of informative display here, but it's not going to do anything but what you see already. I don't know. I'm holding onto the radio, so if I stop holding the radio, it makes a big difference. This is a metal cabinet, and it makes a big difference when you're holding it. Some strange effects here. So what I wanted to look at, I know what I wanted to. I wanted to dial this into the IF. Yeah. What am I doing here? Let's go back to the frequency here. Okay. I'm going to go a little further over. And then we're going to tune it way down to 455 here. There's 440. Now when you look at the display, you see it bouncing along like that. A lot of that has to do with, I believe, it's the same effect as taking a film of a car tire spinning, but it looks like it's standing still. Just the timing of the shutter and the timing of the action, and to some degree that's what's going on in these things, I think, all these SDRs. So you see the signal, like the whole thing bouncing up and down in some kind of pattern, like you see here. I think that's SDR sort of thing happening. So 440, let's put it right on 455. Okay, so right in the center is 455. And you know, this radio's sensitivity is going to be rolling off around this. Is that true? 455. Well, it will have rolled off from way up here. You know, the radio tuned to the bottom, you might get more or less. You get less of this because of less roll off. Well, that's interesting. If you have an IF signal leaking through, the IF signal is going to be leaking through here. It's going to be suppressed by the front end tuning response. The tuning response is moving up and down the band as you tune the radio. So if you're tuning up to the high end, you have the tuning response move to the high end. You have the greatest depletion, knockdown, quieting of the IF frequency, and everything else down low as you're shifting this curve up. So that should mean that if there's an IF signal leaking through the radio because you've got one in your house, you got an IF noise in your house or something, tuning to the top of the band should make it quieter. Tuning to the bottom should bring it louder, while at the same time sounding kind of consistent all the way. Yeah, that's a pretty good theory. I wonder if there's any truth in that. But looking back at this is not revealing any kind of particular like noise source at around 460, which is I believe there is one. You know, there is something right there, but I don't think this radio is gonna. Let me put the problematic. Is it cheap radio? Some of the things you see on this radio anyway, some of these peaks that are out here, they're actually false. This radio, like this one here, I'm tuning the radio and it's staying in one spot on the screen. Oh, it's a false thing. Okay, this is not helping. This is not helping. That's kind of, every time I brought this radio out to do noise hunting, that's how it ends, with me going, this is not helping. It's not helping. Okay. Do we stick with this curious, is the IF full of noise here situation? Why don't we look at the SDR on the computer itself and see if we can spot some kind of IF frequency noise there. Okay, here's a look at what my SDR is seeing. Excuse me, for an antenna on the SDR, I have just a clip lead, piece of wire, maybe a foot long, just a little hanging in my shop. I'll show you in a minute. And I'm going to touch that wire with my finger. And there you go. You can see that it is really the SDR. Now, we see a number of strong things on here. See something strong here, here, and here, and most importantly, right here. This one is at 480. So the 455 is somewhere around here, right in this area. So the question would be then, can a signal like this sneak into the radio through the antenna, through the front end tuning, and arrive at the mixer tube, and then just zoom through the mixer tube, and there it is in your IF, and it's there no matter where you tune. What does this actually sound like? So I'll turn the speakers on here. Not much to it. 480 is pretty high in frequency. If this was 460, I'd be very concerned about this whole effect. Or is there something else down here? Huh. How could you determine? Well, if it's this signal, it's going to come through at 480. It's not going to change frequency. Well, it's going to mix up with other stuff in the mixer tube. Ooh, that would be a complicated situation. 480. What, you put another 480 in with a signal generator and beat them, and then hear the beat? I gotta think about this a little bit. Well, let me just turn the sound off here. Yeah, how can you tell that this is really happening? Of course, you could pass a test signal from a signal generator through the IF frequency and see if, hey, I'm going to do that. I'm going to do that a little bit. That should open my eyes to a few things here. Okay, good, but I think my coffee is waiting right now. Okay, let's switch on the radio again, and I have the signal generator over here operating. Let's just check the calibration on it. Whoa, way high. Someday I'm going to burn this meter out. I can just see it coming. Okay, and we're going to modulate it with 1,000 hertz tone, and that's the frequency it's running at right now, 450. And the output of the signal generator is right on the antenna. It's a metallic connection to the antenna lead, but the signal generator ground connection is not made to the radio just yet. We'll start like this. You can actually see the, just do this, and do that. Okay, there we are. That's the antenna there. Okay. Well, what do we hear? We don't hear anything. So we're looking for 1,000 hertz tone coming out of the radio. I'm going to tune it around a bit. We'll see what happens here. It's a very low signal, so maybe it's just too low. And I don't have the ground connected, so I'm not pumping it right in there. Let's hunt around here. Watch this. Okay, don't hear a thing. 10 times stronger. Nothing. Ooh. What happened there? Hey, so some other noise interference just went away. You can still hear a consistent noise in here. Something happens down in this area here. But up here, doesn't change at all. Okay, let's go another step up. This is a pretty strong signal on the antenna now. Speak of the devil. 471. Of course, I haven't done the alignment on this radio yet. So I guess what we're finding out here is where the IF is tuned at the moment. I'm going to put the ground wire onto the chassis here. That's knocked out a fair bit of sound because the antenna now is essentially shorted out by the signal generator. So all that should be here is a signal generator signal. That's interesting. So it's showing up in two places. 470 and very broad 444. Wow, is this radio just way out of alignment, or is there something odd about what I'm doing here? So a really good radio, you would never hear this frequency coming out of this radio, in a really good radio. But you would need a really good radio for that. One evidence of a good radio is instead of 5 tubes, it has 6. It has an extra tube in the front end, and that extra tube will deal with this problem, along with other things. But it would probably, next time I get a radio in here with a front end amplifier, an RF amplifier tube, I'm going to run this test again. Particularly if you remind me, I will run this test again. So now, what are we finding out exactly? This is a pretty strong signal. It will go through the radio, no surprise at all. I've done this tons of times. Why am I thinking this is weird? I often push the IF frequency into the radio through the antenna, knowing that there's a certain amount of suppression of the signal due to the way that radio has a tuning curve. But as long as you pump it up high enough, some goes through, and then I do the IF. I wonder if I should fool with the IF right now. I mean, I'm right there. Who cares about the bad capacitors? Let's just keep going. This looks like this will be today's topic right here. Right here. So, is there a chance this has nothing to do with the IF? I can't believe it. No. So I'm going to turn some of these IF screws, and we'll see if the tone goes up or down. Oh, smokes! I can't throw it. I can't turn it. It requires a bigger screwdriver. Oh, it's a big one. Oh yeah, sure. Yeah. Okay. 2 frequencies. How come 2 frequencies? Let's go up to the other one. 470. So what I would guess is going on here is these transformers are not tuned to the same frequency. They're tuned to 2 different frequencies, and both of them are getting through. That's my guess on that. So let's set this properly. Wow, very quiet. Ooh, what's that? Where'd that come from? So this is supposed to be, I don't know, I don't remember, 455? Let's start there. We can always move it later. Okay, peeking this up, just using my earballs to hear it. Now we should be doing this with a meter to get it really accurate, but at this point in the process, this is just fine. Okay. Now, does the radio still respond to 2 different frequencies, or is this the only one now, 455? Nothing more down there. Qu'est-ce que c'est? Didn't seem right. It seemed like it got a little stronger at about 465. But that weird thing is there. Let's put that weird thing on. Just trying to, what is that? This frequency is going up and down. The pitch. Okay, so here's my guess at what we're hearing. We're hearing a oscillation. This is a wild guess. Okay, so don't write this down, anybody. We're hearing an oscillation. We're hearing the effects of an oscillation in the IF circuit, which you normally cannot hear, but when you bring up another frequency close to the oscillation in here, you then begin to hear the heterodyne, and that's why the pitch is going up and down, up and down. It's a heterodyne. You know, the distance between the two signals is changing. The reason it's garbled is because there's some intermodulation due to hum coming in the picture too. Is any truth in any of that? Who knows? Well, we still have those 3 terrible capacitors in there. I think what I'm going to do, I'm going to stop here today because I really want to go outside and take advantage of the wonderful weather and the like. I think my wife has some yard work for me to do too. Tomorrow, what we'll do is we'll kind of re-examine the situation here, like, you know, sort of refresh the situation here with these weird tones. Then I'll go after those 3 capacitors, and then we'll repeat this and see if those weird tones are still there, or if by replacing these old capacitors, I eliminated it, and then we can probably be fairly sure about what it actually is. Okay, sounds like fun. That's what I'm trying to do, is have some fun here. I'm going to go outside and have fun. So thanks a lot for watching this video. It's a little short, but we'll carry on tomorrow. See ya.